So this is the 6th lesson in the 3rd quarter. Still working on Unit 2. We're going to jump into multiplying decimals. So we've done some estimation with decimals, but now we need to learn how to actually calculate it without a calculator. We have to actually be able to do the work by hand. So I started this with a warm-up on just normal multiplication, just to get us acclimatized, just to get us comfortable with multiplication. So this little star, a lot of kids are unfamiliar with the fact that that star means to multiply, so I also included multiply to get your answer for each question below. So there are lots of ways to multiply. If you need a review, you can do the standard algorithm, 23 times 6. 6 times 3 is 18. I carry my 1 in my tens place. 6 times 2 is 12, and 1 is 13, so that'd be 138. I could also do lattice. A lot of kids are comfortable with lattice. So for lattice, we make this box with a box for each digit across and each digit down. 23 times 16. And then we add these diagonal lines to separate out our place values. Then we multiply. I'm going to make my pen smaller. 3 times 1 is 3, so that's 3 ones and no tens. 3 times 6 is 18, so that's 8 ones and 1 10. 6 times 2 is 12, 2 ones and 1 10. And 2 times 1 is 2. 2 ones and no tens. And then you add across your diagonal lines. This keeps your place value in order. So we have 8 ones. We have 3 and 1 is 4 and 2 is 6 tens. So that's 60. We have 2 and 1 is 3 hundreds, and we don't have any thousands, so this is 368. And you could also look at it as partial products. 54 times 38. So this is very similar to the standard method. It just breaks it up a little bit more to help preserve place value, because a lot of kids forget when they move to the next line to add the tens place 0. So this helps prevent that by actually looking at the individual place values of the number. These are your ones, 8 ones and 4 ones. 8 times 4 is 32. But then when you do 8 times 5, it's not 8 times 5, it's 8 times 50, because it's 54. And 8 times 50 is 400. And this isn't 3 times 4, it's 30 times 4, 38. 30 times 4 is 120. And this isn't 3 times 5, it's 30 times 50, because it's 3 tens and 5 tens. 30 times 50. 30 times 50 is 1500. And then I just add everything up. 2, 3 and 2 is 5. 4 and 1 is 5, and 5 is 10. Carry the 1. 1 and 1 makes 2. 2052. Okay, so this is, it's just to help remind kids about the place value that you're using. I'm going to show you another way to do that, but it's called grid method, that really helps to break it down. So grid method for 127 times 44. Let me make that a little bit further apart so I can fit this. Okay, so this is multiplication, and I make this little chart to help me. It's 100 plus 20 plus 7 times 40 plus 4. So I actually take apart my numbers according to their place value. You could take apart the numbers any way you want and multiply them, but if you take it apart by place value, then you get these numbers that are much easier to multiply. For example, 7 times 4, that's on my multiplication tables, that's 28. 7 times 40, well, 7 times 4 would be 28, but I have 10 of those, so it's 280. 20 times 4 is going to be 800. I'm sorry, 20 times 40. 20 times 4 is 80. 100 times 4 is 4,000. And 100 times 40. And 100 times 4 is 400. And then I just add my numbers together. So I'm going to go ahead and add each down and then add them all up. So 4,400 makes 4,400. 880 makes 880. And 280 plus 28 is going to be, I'm going to have to end up carrying, it's going to be 308. So I have 8, that would be 15. 4 and 1 makes 5, 55, 88. So I did the same thing with this that I did with my partial products, but I broke it up so I could really see it. Because here I see sometimes kids sometimes forget. They'll do 3 times 4 instead and do all the others correctly, but do 3 times 4 instead, and it messes up their whole answer because they accidentally have 12 instead of 120. When you do it with the grid, it's at least easier to check your work, because you go back and you say, oh, I put 400 for this, but 40 times 100 can't be 400 because that's what this one is. Makes checking your work much easier. Okay, so the objectives for this lesson are that we will revise the definition for multiplication that we developed in elementary school, and that we will use different representations to multiply decimal numbers by one-digit whole numbers. So, in elementary school, kids frequently learn that multiplication makes numbers bigger. And students have this packet in front of them in class, so they're filling in the blanks as we go along. So, we're revising the definition of multiplication to make it more accurate for what we're learning in middle school. So to multiply means to make a number of sets or groups of another number or thing. So when we say 4 times 5, what we really mean is 4 sets of 5 or 5 sets of 4. So multiplying can make a number bigger, but it could also make a number smaller. So if I multiply by something bigger than 1, then my answer is going to be bigger. So if I had 1 of something and now I have 2 of something, I have more. But if I multiply by something less than 1, then my answer is going to get smaller. If I had 1 of something and now I have 0.5 of something, I have less than before. But it's still multiplication because it is 0.5 sets of 1. We're going to look at some ways to represent 4 times 5 because kids are used to seeing 4 times 5 with the x. But in middle school, they start to move away from using that x because we start to get into algebra, and you have variables, and x is your most common variable, so that can be really confusing. So we start looking at other symbols for multiplication. Like in the warm-up, we used that star. That's also multiplication. You might also see this solid dot thing. That one's tricky because if it's too low, it could look like a decimal. And then, most frequently, you'll start to see parentheses used to represent multiplication. So 4 times 5 could be put in parentheses. They could both be in parentheses, or maybe just one of them is in parentheses. So this would be 4 groups of 5. And parentheses are a grouping tool, so it really relates to multiplication because multiplication is groups or sets of something. So, from there we start moving into multiplying decimals by whole numbers, and we're doing single-digit numbers, keeping it simple at first. We're going to represent it 3 different ways. And later on you'll have an option of doing estimation instead of repeated addition. But at the beginning, repeated addition is really helpful to tie into our pictures and our multiplication to keep those together. So I have a space for a key. We're going to come back to that after we look at 1 2/10 times 3 with a model. So this is one whole. This is what we're going to call a whole. So one square, a big square, is a whole. It takes 10 of these blocks, 10 of these blocks to make a whole, so these are tenths. You can actually see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those blocks in this square. So each of those is a tenth because it takes 10 of them to make a whole. So this is 1 2/10. But my problem says 3 groups of 1 2/10. So this is only one group of 1 2/10. So I'm going to need another group that's 2 groups of 1 2/10. And now I need a third group of 1 2/10. Then I can just count up my pieces. I start with the smaller pieces. I have 1, 2, 3, 4, 5, 6 tenths, and 1, 2, 3 wholes. So we're going to go ahead and represent that with symbols. We're going to use a square to represent a whole or a unit. We're going to use a line to represent a tenth because it took 10 of the lines to make a square. And then we're going to use a dot to represent a hundredth. Because, going back to my picture, if I had 100 of these, it would make one of these. So that's why I don't want to draw teeny tiny squares. It would take too much time, so I'm going to use a dot to represent that little square. So when I draw this picture, it's going to look like this. 1 2/10 is 1 square and 2 lines. 1 2/10. Now I'm multiplying that by 3. So if this is one group of 1 2/10, this is 2 groups of 1 2/10, and this is 3 groups of 1 2/10. 1, 2, 3. And then I count it up. I get 1, 2, 3, 4, 5, 6 tenths. Tenths go behind the decimal. And 1, 2, 3 wholes. 3 and 6 tenths. If I represent this with repeated addition, it's 1.2 plus 1.2 plus 1.2 is 6 and 3. And if I represent it with multiplication, it's 1.2 times 3. 3 times 2 is 6, and 3 times 1 is 3, and there's, of course, a decimal in there. Okay, so you can go ahead and try with this one. You can pause the video if you want to just try it on your own and see if you can get it. But when you're done, let me show you what that should look like. So you have 5 groups of 2 and 1/10. So that's one group. I need 5 groups. 2, 3, 4, 5. So I have 1, 2, 3, 4, 5 tenths and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wholes. 10 wholes. Okay. I'm not going to do repeated addition. You can do it if it helps you. I'm going to use this as estimation this time. If I estimate, it's approximately 2 times 5, and 2 times 5 is about 10. And this is close to 10, so that makes sense. And then 2.1 times 5. 5 times 1 is 5. 5 times 2 is 10. And a decimal. Okay, This is where it starts to get a little bit harder. I might do one or two more examples after this, but this is the first one where you might really need to see some extra support. So this is 3 wholes and 5/10. I need 4 groups of that. So that's 1, that's 2, that's 3, that's 4. Now, when I start to count up my tenths, I run into a problem. I have 5, 10, 15, 20. 20 tenths. Well, I'm not going to write that as 0.20 because that's not 20 tenths, that's 20 hundredths. It's 2 tenths. So I need to do something different here. Let's look at our picture, our manipulatives, to get an idea. This is 2 tenths, right? If I break up 2 tenths, I get 20 hundredths. That's why I told you couldn't write 0.20, because 2 tenths and 20 hundredths are the same. But what about this? This is 1 whole. If I break up 1 whole, I get 10 tenths. If I break up 2 wholes, I get 20 tenths. So 20 tenths is the same as 2 wholes. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 20 together. And you saw I broke it up. 1 whole is the same as 10 tenths. So that means that whenever I get 10 tenths, I can cross it out and replace it with a whole. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to replace that with a whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I replace that with a whole. Now I can count my holes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 holes. And no more tenths. I cross them all out. Let's show that with repeated addition, because that will really help to clarify. 3.5 plus 3.5 plus 3.5 plus 3.5. That's 5, 10, 15, 20. Put the 0, carry the 2. The 2 that we carried, that's these 2 squares. Okay, so we got 20. We put the 0 down. We carried the 2. We're putting the 2 into the ones column because it's 2 ones. It's not 2 tenths. Then I can add up 12 and 2 is 14 and drop in my decimal. Same thing with the multiplication. 5 times 4 is 20. 4 times 3 is 12 and 2 is 14. Drop in the decimal. So that's where it gets tricky, is combining. Let's look at a different example. Let's add in some hundredths. So if you refer back to our key, we said that a box is 1, a line is a tenth, so we have 2 tenths, and a dot is a hundredth. So we have 1 and 2 tenths and 4 hundredths. 1 and 2 tenths and 4 hundredths, or 1 and 24 hundredths. Now, remember we broke up 2 tenths into 20 hundredths, so I know that those are the same. And drawing 2 lines is easier than drawing 20 little dots. So even though it's the same thing, to make it easier on myself, I went ahead and did 2 tenths instead of drawing 24 hundredths with 24 little dots. Now I need 3 groups of this. So that's 2, 3. Same as before, 10 hundredths make a tenth. See, 10 hundredths make a tenth. So I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths and replace it with a tenth. And then I just have 2 hundredths left. So what I get is I am going to have 2 hundredths in my answer. I'm going to have 1, 2, 3, 4, 5, 6, 7 tenths in my answer. And I'm going to have 1, 2, 3 wholes in my answer. 3 and 72 hundredths. As repeated addition, I'm adding 3 of those together. It's 8, that's 12. Carry the 1. There's the 1 that I carried. 6 and 1 is 7, and that makes 3. Same thing here. It's 12. Carry the 1. Carry the 1. It's 3 times 2 is 6, and 1 is 7. 3 times 1 is 3. Let's see if there's any different ones to explore. This is the only other one that might give you a little bit of trouble because there's no tenths. So when I draw this picture, it's 1 whole and 3 hundredths. No tenths. And then I need to make 6 copies of that. 2, 3, 4, 5, and 6. I know I can get at least 10 hundredths out of that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths makes a tenth. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So I have 8 hundredths, 1 tenth, and 1, 2, 3, 4, 5, 6 wholes. Now, in this case, because there weren't any other tenths, I had 18 hundredths before, I have 18 hundredths now. And that's okay, because there were no tenths to add to. If there had been tenths to add to, then I couldn't have just written 18 hundredths. I'd have to add the tenths part to the other tenths that I already have. I'm just going to show this one as multiplication. 1 and 3 hundredths times 6. Well, 6 times 3 is 18. Carry the 1. 0 sixes is 0, plus 1 is 1. 6 times 1 is 6. Okay. And again, the 1 that I carried, I also carried in my pictures. Okay. So that's about it for this. Alright, from here we're going to move on to multiplying by tens place numbers. So it's important that kids really understand the pictures and especially the regrouping where we cross out 10 to make the next bigger picture, so they'll be prepared for the next lesson.